Welcome to this video, and in this video we will learn about geometric symbols used in GD&T. We will also learn about current and previous standards and some basic terms like datum and allowable variations. In our previous video, we have learned about introduction to GD&T, scope and benefits of using GD&T. So in case you have missed the previous video, I will encourage you to watch that short introduction of GD&T. You can find the link of that video in I button above and also in the description as well. So let's begin with this video. First, let's talk about current standard used in industry. So current standard that is being used in industry is ASME Y14.5 2018. And previous standard that was being used was ASME Y14.5 2009. So what ASME stands for here? ASME. It basically stands for American Society of Mechanical Engineers. Okay, American Society of Mechanical Engineers. Now let's talk about geometric symbols that are used in GD&T. So there are 14 main symbols and we can divide them in 5 major categories. And let me tell you about these 5 categories. First is form, profile, orientation, location, and runout. Now, before explaining you these 14 symbols, let me tell you about some basic terms. And first is datum. Imagine that you are currently standing at point B and you are 1400 meters away from point A. And imagine that this is your home. So, point A is your home. You are 1400 meters away from your home. And you can tell that I am 1400 meters away from my home. So, here your home or point A is reference point that you are giving, and that same reference is called as datum. Let's see another example. Let's say you are standing at point B and you are 2000 meter away from a wall, and this wall is actually a datum because you are just giving a reference that I am 2000 meters away from this wall. So this wall is called as reference or datum point. So I hope that datum is clear for you now. It's nothing but a reference. It can be a line, it can be a point, or even it can be a plane. Okay. So now moving on to our next term, that is allowable variation. This is acceptable range of deviation ensuring parts meet design requirements. Now let's discuss these symbols along with their respective category. So first category is form, and in this we have 4 different symbols. Straightness, it actually ensures a perfect line. Flatness ensures a perfectly flat surface. Circularity ensures that we have a perfect circle, and cylindricity ensures a circular surface and a cylindrical straight axis. So all of these 4 symbols do not require any datum or any reference. Okay, so form do not require any datum. Moving on to our next category, that is profile. So in this we have profile of a line along with its symbol and profile of a surface along with its symbol. So sometimes it requires a datum and sometimes it does not. Third category is orientation, and in this we have 3 symbols: angularity, perpendicularity, and parallelism, and all of these require a datum or reference. Let's suppose if a surface is perpendicular, so perpendicular to what? Some other surface, and that other surface is called as reference or datum. Similarly, this goes to angularity and parallelism. So a surface is parallel, so parallel to what? Some other surface, and that other surface is a datum. So orientation require datum. Fourth category is location, and in this we have 3 symbols. Position is location of a feature. Concentricity is when 2 features share same center. Symmetry is equal distribution of material about a datum. And all of these 3 symbols require a datum. So location category also require a datum. And same goes to our next category, that is runout. In runout, we have two symbols, circular runout and total runout. And here, let me tell you about circular runouts. It actually controls the circular movement. So, what exactly is? Assume a cylindrical surface like a cylinder and it is rotating smoothly. And here, circular runout assesses its radial and axial variations. And total runouts control all geometric variations simultaneously, like form, orientation, and location. So that's all about geometric symbols, and in our next video, we will discuss modifiers and its symbols. See you in the next video.